We're now going to start with our first and easiest case, and that is when we need to decompose distinct linear factors. So suppose we start with the rational 2x minus 1 over x plus 1 times x minus 2. The first thing we're going to do is we're going to recognize that because these are distinct, we have a possibility of having an x plus 1 and an x minus 2 term, partial fractions of this 2x minus 7. We just don't know what they are yet, so we're going to use the variables a and b to represent that. Our next step is to treat this as an equation and to solve, so we're going to multiply both sides by the factors. And then we distribute on this side, so each one will get both, and notice that some of them are going to divide out. But on this side, everything divides out. So we end up with 2x minus 7 equals a times the pieces it's missing. In fact, let me write them in blue so they stand out. X minus 2 plus b times x plus 1. Because notice the x plus 1 will divide out here and the x minus 2 will divide out here. Well, this is almost ready. We just need to do one more step. We need to distribute through. And so when we distribute through, that's going to give us 2x minus 7 equals ax minus 2a plus bx plus b. Now the last thing we need to do is to find a way to solve for a and b with the 2x minus 7. But we know that in order for this to be true, the ax and the bx have to add up to the 2x. So 2x is equal to ax plus bx. I'm going to make this a little bit simpler in just a minute, but I want you to see this step. And the minus 2a and the b have to add up to minus 7. Minus 2a plus b. And notice that now we have a system of equations with two variables and two unknowns. And this is really, really, really good news, because what we're going to do is we're going to pretend that these x's aren't here at all. So we're going to have an x and a constant line. And so if these go away, then it's really easy to solve. And the best way to get those to go away is just to divide by it, but don't even write them in the first place, and you'll still be okay. Well, when we solve this, we already have our a by itself. So we're going to take 2, and we're going to add 2 times a to it. So we're going to add 4, 2a, and 2b. That gives me 2 equals a plus b, and minus 3 equals 3b. Well, looking at this equation, it's real easy. If 3b equals minus 3, then we divide by 3, and b equals minus 1. Go back to our original equation, or our first equation, 2 equals a plus a minus 1, or 2 equals a minus 1. Add 1 to both sides, and a equals 3. So if we come back up to our original, we now know that a equals 3 and b equals minus 1, so I can rewrite this as 3 over x plus 1 plus a minus 1 over x minus 2. Don't quite like that, so let's move the minus to the front. And this now is our partial fraction decomposition. We have decomposed 2x minus 7 over x plus 1 times x minus 2 as 3 over x plus 1 minus 1 over x minus 2. And we have successfully solved that problem. Now I want to look at another one because sometimes they're not quite that easy. Suppose we have 3x squared plus 4x plus 3 over x cubed minus x. And the very, very, very first thing that we want to do is we want to take our denominator and factor it. Leave the numerator alone. Only factor the denominator. But this gives us x times x squared minus 1, which is x plus 1, x minus 1. And we have 3 distinct linear terms, which means we're going to end up with 3 terms here. And they each get a single variable on top, an a, a b, and a c. And now we do the same thing we did before. We multiply everything by x, x minus 1, x plus 1. And that gives us the equation 3x squared plus 4x plus 3 equals a times x plus 1, x minus 1, plus b times, I should be writing that in blue. Notice I'm only writing it by what it's missing. x times x minus 1 plus c times x plus 1. We'll multiply this all out. So this is x squared minus 1, this is x squared minus x, and this is x squared plus x. Distribute the a, the b, and the c through it, and we get 3x squared plus 4x plus 3 equals ax squared minus a plus bx squared minus bx plus cx squared plus cx. And here, we're ready to go. We're going to start, and this is how I do it. I'm going to list an x squared off to the side, and I'm going to say I've got an ax squared. So I'm just going to take the a part of it. So this is my x squareds, the a, the b, and the c. So a plus b plus c equals 3. For my x's, I have a minus bx and a plus cx. So I'm going to get minus b plus c equals 4. And for the constants, I'm going to get minus a, let's write that in black, equals 3. And notice that no b or c is a constant, it's just the minus a. So this is my system. And this is really easy because now we know that a is minus 3, which is very helpful because then I can ignore this equation entirely and focus on these two. I get minus 3 plus b plus c equals 3, and minus b plus c equals 4. If we add the 3 over, so when we added 3 to both sides, that makes this a 6. So b plus c is 6, and minus b plus c is 4. That's actually already ready for elimination. I'm not going to bother with the Gaussian method. I'm just going to add. I'm going to get 2c equals 10, which makes c equal to 5. And if c is 5, then b plus 5 equals 6. So b equals 1, which makes sense because minus 1 plus 5 is also 4. So now I've got a, I've got c, and I've got b. So I come back up here. If a is minus 3, b is 1, and c is 5, then this turns into a minus 3 over x plus 1 over x plus 1 plus 5 over x minus 1, and I have now broken this up into its partial fraction decomposition. The major idea is factor out your denominator, create your terms, multiply both sides by the denominator to clear it, and then group, after distributing, group all your pieces together and solve the resulting system.